chamar aqui ao palco Matthew Reyes. Matthew Reyes é CEO da empresa Exploration Solutions. Então, ele é consultor da NASA, ele é estrategista de tecnologia emergente do Centro de Pesquisas da NASA, certo? Ele trabalha no desenvolvimento de satélites e iniciativas avançadas de fabricação da NASA para melhorar o programa espacial. Depois de 4 anos como diretor de operações técnicas da Zero Gravity Corporation, cara, não é por nada não, só para dar uma pausa aqui, mas um cara que trabalha, que foi diretor de operações de uma empresa chamada Zero Gravity Corporation, caraca, que coisa massa, hein? É certo? Have you ever been Zero Gravity? Have you ever been Zero Gravity? Oh man, 2,000 times. I envy you. Oh man, you're okay. That's so cool that I lost where I was. Ok, então ele fundou em 2007 a Exploration Solutions, empresa focada em melhorar a educação científica e a sensibilização do público através da produção em alta definição, multimídia interativo para salas de aulas e museus, assim como internet e televisão. Matt participou e avaliou dezenas de voos em microgravidade, além de centenas de voos parabólicos a bordo de várias aeronaves. Recebeu a certificação NASA Center como cientista suborbital com intenções de trabalhar no espaço, certo? E aí tem mais um monte de coisa aqui. Ele se formou na Universidade da Flórida, se formou em horticultura ambiental, tá certo? Na Universidade da Flórida, tem vasta experiência em campos bem diversos, como computação, biologia evolutiva, horticultura, paisagismo, concerto de motocicleta, fotografia, rádio, astronomia óptica e arqueologia subaquática. Caraca! You're probably the coolest person that ever walked into this stage. Ok, tá certo? Já escreveu para a revista Marca, foi entrevistado pela Wired, Popular Science, caraca, tá certo? É o mestre do do it yourself. Com vocês, Matt Reyes. Oh man, you're just so great. Thank you. Thanks for coming, man.
Yes. Hi. Well, yes. So it was a translation. Hopefully, it wasn't too long of the things that I've done, but I've been very lucky to do a lot of the things that you just heard about, and I'm really glad to be here to be able to share with you some activities that you can do to actually help me and help the rest of the world, and we'll get into that. But yeah, that's me. In fact, that picture right there was where. There we go. That's better. So that photograph right there is actually of me floating around inside of a 727 aircraft. In English, it's called the Vomit Comet, but it's an aircraft that basically flies like a roller coaster, okay? And when it's going over the top, you get to float around inside like an astronaut. This is what we use to train astronauts on how to perform in microgravity. The thing that I used to do, however, was evaluate payloads, evaluate structures that would go inside of this 727 to make sure that they were safe and to make sure that they would be successful in their operation. So from that background, I work now at NASA Ames Research Center, which is just south of San Francisco. And the research center is very interested in developing small payloads that go into space, things like satellites, things that float around inside the International Space Station. And one thing that's very cool about the center that I work for in San Francisco is the fact that we develop international partnerships. So we can figure out ways to actually work with other countries to develop these kinds of technologies together in a partnership. The specific role that my company that I own is I advise the chief technologist of the center. The chief technologist is responsible for, responsible for identifying technologies that the NASA Center needs, but also identifying the technologies that we make inside by the government and try to push it out the door, try to commercialize it in a way. Other things I do is I blog for Make Magazine, and a big part of my time is spent developing art projects for this event out in the western desert of the United States called Burning Man. Has anybody heard of Burning Man? I'm just curious. If you raise your hand. Okay, a couple. All right. One thing that I need to be very clear about is that I'm not an employee of the federal government of the United States. I own my own company and I'm contracted. So the things that I'm talking about are my personal opinions, my personal stories. They don't represent the United States or the agency that I'm contracted to work with. So one of the key things that I like to really talk about when I'm engaging people to come work for the center, to build hardware for the center, or even program software for the agency, NASA, is to really highlight the fact that the history of aerospace, the history of aviation in the United States and across the world is actually one made by many individuals. So there's nothing, even though it seems special, there's nothing unique about what NASA's accomplished and what the United States has accomplished in terms of spaceflight. And a lot of the history we'll find is shared in different countries in just different ways, but by individuals, people like you who could just come up with an idea and do something about it. Here we go. So one of the big pushes that NASA tries to get to the citizens of the U.S. is this notion of participatory exploration. The idea that we can explore the planet and explore outer space together in a way that allows individual citizens to develop solutions or come up with ideas or think of new ways of asking questions about the universe. There's this term we love here, of course, hackers, that some people in government are afraid of. It's gotten, at least back home, a little bit of a bad name because people think of, or I should say authorities think of people who may be doing bad things, but we know that hackers are actually a cool thing. And so one thing I want to try to stress is that the notion of hacking is not something that people should be afraid of, but some people are. So we try to use other words in English such as tinkering or making, makers. And in fact, there's this big, and in fact it's becoming a global movement called the maker movement, which is this enabling community, it's a community, it's a movement that empowers people, that encourages people to make their own things. That's software and hardware, something that Campus Party has been doing and incubating for a long time. It's not new. And this, to go into the history of aviation, we know the history of the Wright brothers. In the United States, the Wright brothers are the inventors of aviation. Although if we look back, there's some lack of clarity on who, in fact, was in the air first. When I gave this talk in Berlin, I wanted to make certain that I acknowledge the fact that Albert Santos Dumont was a great aviation pioneer and was flying over France in 1909 in this picture, and the Wright brothers had come across to Tempelhof Field, which is where the Berlin Campus Party was, and brought their aircraft at the same time, and these folks were exchanging ideas. But we're talking about three individuals. We're talking about Orville and Wilbur Wright, and we're talking about Albert Santos Dumont. And so they started up their own concept of how they were going to fly within just their own minds and a small group of people. Now, one of the things that happened with that wonderful idea is, unfortunately, other practical uses. The government got very interested in being able to figure new ways of doing, or of using aircraft. And of course, at the same time, we're starting to see World War I. So the use of aircraft was introduced into the battlefield, and the government really forced a demand to build many aircraft in a short period of time. But one of the weird things that happened is that all of these all of these other folks who were coming out with interesting, cool designs, they were finding out they didn't exactly work right, or they had some cool ideas, but they really needed some help to get their ideas off the ground. So the United States government actually in 1915 copied something that the United Kingdom government did in developing a council for just aeronautics. And in the United States, it was called the National Advisory Committee on Aeronautics. In 1909, the British actually pulled it off, and it was called the British Advisory Council for Aeronautics. So we were not original in our naming either. But after World War II ended in 1918, a really cool thing happened. We had a whole surplus of aircraft all over the world. And I'll speak more about what happened in the United States, is that people started taking these surplus aircraft and then hacking them and then flying them around in maybe unsafe ways. In fact, very unsafe ways, because we saw a lot of aircraft starting to crash over neighborhoods, over homes, but in doing acrobatic maneuvers and just small or short distance transportation, this barnstorming era, as we called it. And so, and here you can see an example of the kind of crazy acrobatics that were going on. And so what the government at that point realized is that they have to start regulating how aircraft are going to be purchased and flown over people's heads. So at first we have not the best influence of why government needed it for warfare, but we all of a sudden start seeing a civilian benefit to government interference, if you will. So not every little bit of government involvement with these programs is negative. I want to stress that. Now, moving forward, 1920, not too far forward actually after World War I, but Robert Goddard, and then 23, actually a gentleman, Hermann Oberth, a German, these two individuals developed the technologies on paper and in hardware, the actual rocket systems, the simple prototype rocket systems that we still use today. And so, but this is all the way back in the 20s, and still note individuals. Now, Hermann Oberth was funded by German government money, and Robert Goddard was a professor back in Maryland. And so they did have academic influences, but they were fundamentally hackers in their own right. But one of the key things that I really love pointing out, these are not the first space explorers at all. And it wasn't the Russians either. And it's actually, we've been doing it for a very long time, if you consider the fact that observatories have been exploring space from the ground way back. And so, you know, and it's not just one culture, but it's many cultures have been developing different styles of observatories for their culture-specific needs. In some cases, it was for, unfortunately, in some cases, it wasn't always for the curiosity of what's going out in outer space, but it is, they were looking for tactical advantages to understand what was going on with crops. But in some cases, too, we come back to the unfortunate theme of warfare. But fast forwarding several thousand years, of course, we all know Galileo. I like to call him one of the first telescope hackers. He actually took somebody else's telescope design and then tweaked it so that he could look up at the stars. And that's when he started observing the moons around Jupiter and really freaking out the church, because it really exposed that the knowledge that the community had, that the population had, was not what we were told or what they were told at the time. And I'm sure this may resonate even today. Don't always believe everything that this popular notion of maybe the government or what rumors or what everybody else says. One of the key critical highlights about Galileo, although he didn't invent the telescope technically, he did have that critical thinking prowess to use the tool and come to conclusions that were different than what everybody else told him to, at great peril. And once he figured out how to do it optically and they realized, oh, well, maybe we'll make them bigger, governments got involved again and started building observatories. So we see that exploration starts oftentimes with individuals, but then gets picked up by governments again. And we see, you know, in 1676, the Royal Greenwich Observatory is the oldest observatory of its kind with optical telescopes. But the Torre Malakoff, I'm going to pronounce this wrong, but the Malakoff Tower and the famous Berlin Observatory, this one I believe is here actually in Recife. were built around the same time. So Europe doesn't own the history of space exploration either. But again, as I mentioned, we have to face the reality that when it comes to governments, especially older governments, we're looking at tactical advantages for wartime. They were looking to keep time so they could navigate. They were looking to understand positions of things so they could know where to deliver unfortunate things. And a lot of the aircraft development was really a delivery system, but not for post office. But and then of course the drive for outer space. You know, when the Russians launched Sputnik, it became the big space race. But key things to point out: the space race, as it started, was trying to understand specific hardware to launch that could operate in space. They weren't originally thinking about people; they were thinking about objects, computerized objects, even though they weren't computers at the time, but electronics. Small electronics. So Sputnik was about the size of a basketball, and the Americans' response to Sputnik about a year and a half later was, as you can see, the scale. That's the Explorer 1 rocket. Now that little satellite, that little rocket that they're holding actually went on top of a very big rocket. But that was the first U.S. satellite in space, and you can see Werner von Braun's on the far right. But that was before NASA was formed. In 1958, we figured out that it was important to develop space not as a weapon or as a war field, but to develop for purposes of benefiting all of humankind. And in fact, in the Space Act of 1958, it doesn't say for the benefit of U.S. citizens. It says for the benefit of mankind. And so in 1958, the U.S. government approach to spaceflight changed. Werner von Braun's position also changed, and he developed, as we know, the Saturn V rocket, and actually many of the rockets that were used to launch the early spacecraft. And that right there is the rear end of the Saturn V for scale. If you ever get a chance to come to the United States, there are 2 Saturn Vs that you can come and look at. I would recommend, one of them is in Florida at Kennedy Space Center, and the other one is in Houston, Texas. These are mammoth vehicles. They'll go all the way down. So, but the key thing also about the Saturn V is that these were government projects that were turned into, or these were individual ideas that were turned into government projects that turned into massive government agencies, government structures like NASA is today. The NASA center that I work at has about 4,000, I think it's on the order of 4,000 contractors and civil servants. So it's a pretty big center, but that's actually the smallest it's ever been. It's been almost 10 times that. But the key thing here is that the government also tried to hack its own programs, like the Saturn V. The first space station that we'd ever built was a hack job. That is actually the body of the Saturn V in Skylab on the right there. And of course, we were really just hacking it so we could catch up with the Russians who had developed the space station using their own native technology. So we've always been a little bit behind in how we get our space travel done. In fact, we've been so behind that we have 2 space stations now, with the International Space Station being our second one, with help from the Russians, but really following in their footsteps because they've had several different varieties of space stations, some that have been public, and in fact, many of them have not been. But the thing here that I want to focus on what what I work on and where your capabilities lie is not necessarily on building the space stations and not necessarily going to space, but on what the things you can build to go into space. And so we're used to the big satellites and the big space projects that cost billions of dollars in some cases. You know, we got rovers and communication satellites, some of them as big as a stage. The rovers are as big as cars or golf carts. But we also have the smaller ones, such as a Sojourner probe there on the Pathfinder mission to Mars. It's a much smaller probe. So the scale of things as we've developed is not just big, and it's not just something that we need to launch on a big rocket, but these are the projects that the government bought the other thing we want to highlight is the fact that private individuals are coming back to build their own spacecraft. If you're familiar with Elon Musk, he's a founder, or was one of the principals with PayPal, has Tesla, the electric cars, and of course SpaceX is the rocket company. It's a private company that's actually fighting with the United States government right now because we're not necessarily treating him fairly. It's a very interesting story where we're trying to develop our own independent rocket program, yet we're not exactly doing everything we can to help him out. And of course, Richard Branson is developing, he bought the rights to develop his own personal spacecraft out in Southern California, in the Mojave Desert. And then there's a gentleman that not too many people know about, but his name is Robert Bigelow. And he actually is developing his own space station. That's an inflatable structure right there that he wants to have a hotel in. Robert Bigelow is actually known for the Clarion and for enormously large hotel chains in the United States and actually worldwide. So these individuals, some people call crazy, are spending their own money to develop the ability to go into space or explore space, which is actually not new again either, because what we find is that the history of observatories went from government funding to personal backing. So, for example, the Keck Observatory or the James Lick Observatory here, is actually above the hills where I live. There's a funny story about James Lick where he wanted to build a massive pyramid in the city of San Francisco. And that was going to be his monument for his for the rest of the history of the United States, for everybody to know how cool he was, how rich he was. And so other people, however, convinced him that maybe it would be better if you used your money to build a monument where everybody could see you on top of the hill, but more importantly, you could see out into space. So individuals were getting back into the exploring space notion well before Elon Musk and well before Richard Branson. And so to highlight what's happened recently is that we have access to new kinds of machines, new kinds of computing power. We, as in the public, have access to this new capability that has never happened before. And this new capability is enabling all of the ideas, things that you're quite familiar with, but not everybody else who hasn't come to Campus Party. They're enabling new ideas and how they can build their own things. And my job, obviously, is to inspire you to do things for space. There's a magazine back in the US. Has anybody seen Make Magazine before? I know it's an English publication. Okay, cool. All right, a couple. So I wrote an article for Make Magazine, Space Science Gadgets You Can Make for NASA, and that got a lot of people's attention. And in fact, this whole magazine article was based on the realization from the publisher that people can start making these satellites. NASA developed a system, one satellite that's was actually 10-centimeter cubed. They're called CubeSats. And they developed a way to actually build a satellite using a camera battery. As it turns out, that big block right there is a Canon video camera battery that they use to power a satellite. So this is one of the first examples of using off-the-shelf kinds of components for an outer space exploring technology. This whole satellite in the far corner there, that's a 10-centimeter cubed object. I wish I had one to show you. But it was loaded up on the arm of the International Space Station and then shot out using a spring, almost like a little BB gun. And those satellites orbited the planet for several weeks, actually several weeks, and transmitted home with an antenna. I'll just point out, this antenna right here, this blue line, is actually a measuring tape. It's one of those, it's a cut measuring tape that you can get at the hardware store. Hacking. In fact, you can see a closer version, that yellow right there, that's a measuring tape. That's used transmitting on the amateur radio band, so people all over the world could hear it as it chirped by, just like Sputnik. But one of the other big innovations that NASA was developing at NASA Ames Research Center, in fact, I was involved in the early days, was the development of satellites that could be, it could have a cell phone for a computer. And so what you see here is the actual original Google Nexus 1 Android phone that is inside the form factor, the shape of the CubeSat. Now think about it. The TechEdSat, the satellite I showed you before, was hundreds of thousands, almost millions of dollars in development costs. But now we are being able to use off-the-shelf phones. In fact, phones you can buy on eBay to control satellites. And if you really think about it, you don't need the glass because you're not, you're in space, nobody's touching anything. The battery you can do a little differently. The electronics for the control a CubeSat, a full satellite, are the size of a couple sticks of gum. They're between my fingers there. So if you really think the miniaturization of computers that we're all familiar with as applied to space is something NASA never really thought of before until a couple years ago. And then, of course, the realization it's Android. So who here can program an Android? More hands. OK, so that means you can actually program the control system for a satellite. And so one of the things I just want to highlight here, if this will play.
5, 4, 3, 2,
this is a rocket launch, and this rocket camera right here, this window here, is actually that Nexus 1 inside of that rocket right there. Now this was done, this is a NASA project. How many people do you see out there? You don't see mission control. It's just a bunch of guys out there who built a rocket, and actually 2 women.
Real shit right
built a rocket and launched it. And what you're seeing here with the video, or the lines here, this is actually the accelerometer data inside of the cell phone recording the data. Where we see problems, where the red circles are, okay, so we realize that there are some issues with the limitations of a cell phone, but nonetheless, it's pretty amazing.
Jesus Christ, that went up high.
And that was done, actually, if you know Burning Man, that was actually done over the desert where Burning Man is. So I'm going to skip the rest of that. But this is actually the rocket that went up. That's not the view, but just for a sense of scale, that rocket's about yay tall. Now, the really cool thing about this rocket launch was that a company was formed as a result of the information gleaned from knowing the cost reduction and the size and weight reduction of using a phone. Some of the guys that were in that video, in fact, the guy who made the video, left NASA to start a company called Planet Labs. Planet Labs received $58 million US in funding to develop the world's largest fleet of satellites ever flown, hundreds of satellites. That's one example. If you look at the top corner, there's that measuring tape again. But the point is that they are developing systems that are taking pictures. That's right outside Rio de Janeiro last week. Here's another one I'm going to mispronounce, but this is a reservoir showing the water level change in the big reservoir, the Boa Vista. Okay, these videos just came in last week, and they have more pictures that they're able to take on an almost weekly basis. This has never been done, especially at this price point before. Just to make one point clear, this technology, not much more advanced than what's in the phone. So nobody's privacy is being invaded. This doesn't have the use of a spy satellite, although it can track ships in the water. But the point for this company is that they're trying to educate the world, educate everybody on what the capability is for this kind of imaging. But also, they have developed an opportunity for everybody to develop satellites on their own. One thing I want to point out, these satellites were pushed off the International Space Station as well. So the system is develop a satellite, launch it for an astronaut, and then the astronaut can push it out the space station just like that TechEdSat. Now, who has heard of Kickstarter or Indiegogo? Of course. So the first time that Kickstarter was used to actually fund a satellite project was a project known as KickSat. Zachary Manchester from Cornell University up in Ithaca, New York, needed some funding to develop this satellite that small. It's 1 inch or 2.5 centimeters square, and it's flat circuit board. Okay? And what he was trying to do is develop a system of open source programmable satellites that can deploy in the structure like this, hundreds of satellites. I found Zach on Kickstarter because I'm a geek on Kickstarter, and I invited him to come work at NASA Ames Research Center as a student. My business partner and I helped him design the deployer mechanism, the thing that holds all of those chips. We actually launched on the SpaceX rocket back in May, and unfortunately we had a small malfunction and they didn't spring open. But the key thing is that this system, he asked for $30,000, got $75,000, and we can turn around and get another satellite for almost a little more than half that. The largest the largest launch of individual satellites and the smallest satellite all at the same time. This technology is getting smaller and cheaper, and the programming code that's on here, it's on GitHub. Okay, so if you look up on GitHub for Kicksat, K-I-C-K-S-A-T, you'll find your ability to download and program your own. It's an Arduino-based computer. Since then, there have been other Kickstarters that have gone up. One thing I want to highlight, every single Kickstarted satellite that has gone up has not worked exactly as planned. In fact, far from it. The ArduSat here, he asked for $30,000, got 106, raised a lot more money privately in the millions dollar range, and is still trying to develop his satellite. The SkyCube satellite asked for, I think, asked for 30, got 58. People really genuinely excited about it. Had a small solar panel deployment problem, and but he may come back and do another project because he's learned from it. Key point to take away: low cost. I know that's a lot of money. It's a lot of money to me too. But from a crowdfunding perspective, especially from a government perspective, that's a low-cost space program. This is within reach. But it's also not new because the first small satellites, well, Sputnik we could say, but the first crowd-funded satellite actually is this box right here. It was called Oscar 1. It's a ham radio repeater. That one's about as big as my laptop tall, and launched in 1961. So we're really not inventing anything new. But what is new is the capability to actually build these things. Now, one thing I'd really like to highlight that we can use these technologies for is maybe saving the Earth. So did everybody hear about what happened over Russia 2 years ago about the Chelyabinsk asteroid? It blew up and it busted a lot of windows in people's eardrums. The risk of asteroids hitting the planet is something that we understand. And let me show you, these are the known asteroids that we've been able to map, okay? Look at this cloud. This is a lot of asteroids. Now, we know vast majority of these aren't going to be bothering Earth. We've been able to plot their trajectory. However, we've been surprised. 1 kiloton and larger. Look, this map is something that's very telling. There's a group called the B612 Foundation that is actually seeking money through crowdfunding to develop a telescope to be able to identify the rocks that we haven't been able to find. And here's why. 15 kilotons is equal to the bomb that unfortunately we dropped in Japan. Okay, 20 kilotons, these big red spots that you're seeing, these are massive explosions that are hitting the upper atmosphere. These are things that we're not hearing. Nobody's around, but these will make a noise when they blow up in the sky. Okay, and some of these are overpopulated areas, and some of them have been seen. The 2 over Sudan, in fact, we had a mission to recover some pieces. But these, I don't know if anybody's gone to Indonesia to ask them, but they would have heard that one. That one was right over California, that last one there, and then the red one was the Russian one. But the one that happened over California were reported, police all over that region of California were called because they thought somebody was setting off a bomb. So the point is that, well, actually, I'm going to skip that for time. The point I'm getting at is that we have a real risk of asteroids. In fact, I am going to play this. This is a...
The night sky is a beautiful thing, filled with galaxies, stars, planets, and asteroids. Unlike those other celestial objects, asteroids like to swing by for a visit from time to time. Well, the problem is when they get a little too friendly and crash right into us. But don't worry, there aren't any impending...
Oops. Well, okay, the video's not working well. All right. Well, the point of that video really is to highlight that we have developed at NASA a program called the Asteroid Grand Challenge. And if you look up on the internet, Asteroid Grand Challenge in English, you'll find opportunities to provide input to help us understand what the threat of these asteroids are, but also to volunteer ideas on what to do about them. Now, what to do about them is kind of harder. That's going to need a rocket, but the big problem is identifying these guys. Telescopes are something we're very actively trying to figure how to reduce the price of the larger versions of telescopes to be able to see these asteroids. Asteroids are really dark. Let's see if I have... Well, the point is that the asteroids are really dark objects that are difficult to see. And so if you know anything about optics, if you know anything about control programs, being able to point low-cost multiple telescopes all at the same time, at the same point in the sky from varying different locations, these are the kinds of problems that NASA hasn't quite figured out yet. So please, you're more than welcome to contribute ideas to the Asteroid Grand Challenge website. But the other thing I want to highlight too is that you don't need to be in space. A lot of the exploration that we can do is on the ground. NASA actually had a contest called the Astronaut Glove Challenge, which was we didn't know how to make gloves that wouldn't tear under a lot of work. And you don't want to be in outer space with a glove that tears because you've got an air problem, an air leak problem. So we went out to Western Australia where the rocks are really jagged and found ways to make spacesuits overall, the gloves especially, a little more durable. The other thing, obviously, with rovers and robots is that we have a need to develop really small rovers that can do exploration in really hot environments. That one was right in the Arabian Peninsula, just between Saudi Arabia and Iran, in the United Arab Emirates. And we've also taken these things out to Namibia, which is really important to look at too if you consider the fact that there are places on Earth that look like the planets that we want to explore. Namibia and Mars, that's actually my foot. I took that picture and I was just blown away at the similarity. And then it's hard to see on here, but the tracks that we left with the rovers on Mars, done with the larger rovers, the tracks we've left with the wheels on Mars from the larger rovers, we can leave smaller footprints using, this is an Arduino Bluetooth controlled system. So it doesn't take much more hardening, space hardening, to actually make those things work. So yeah, just to highlight the point that exploring space and understanding how to live in space is really answering a question of how to live here on Earth sustainably. If we're going to go and, if we're going to be able to explore and breathe air and drink water in a recycled way in space, these are technologies that you can help develop that are useful here at home for obvious reasons. So in order to enable that, what I did at NASA Ames Research Center was develop a fab lab. Has anybody heard of a fab lab? Raise your hand. Okay, this is good. So there's actually several here in Brazil. The fab lab is a hackerspace. It's a makerspace that was made at MIT, and they've opened almost 200 of them across the world. There's going to be one opening here soon in Recife, but I invite you, and if you want this list, come to me after and I'll get it to you. I invite you that if you live in these areas, this is online, look this up. They have the tools, according to MIT, the tools to build almost anything. What kind of tools? Well, we have things like mills, the traditional machines, routers, robotically controlled routers. That up there is an animation of a laser cutter, so that's a laser beam cutting through a piece of metal. If it can cut through metal, it can cut through wood and plastic. The really cool thing you can do with machines like that are build structures like this. This was built by the Fab Lab in Seville. Or Madrid, actually, in Spain. And but this is actually plywood that has been cut into individual pieces and assembled like a puzzle. So if you know how to design with a program like SketchUp, which is a Google, or formerly a Google program, or Autodesk has AutoCAD, or these free programs called 123D Make. Okay, 123D Make. You can download these for free, and you can design structures like this. Note the solar panels on top. No, the idea of actually, is IKEA in Brazil? Yeah, so the notion of flat pack assembled furniture is what these machines that I was just showing you can do. These are also the kinds of technologies we're looking at building structures on the moon and Mars. How do you take flat objects, pack them in a rocket, and then expand them largely? And of course, the Fab Lab has the 3D printers. Everybody who hasn't seen a 3D printer yet or knows of what they are, maybe not in person. Has anybody not seen a 3D printer? Raise your hand. Okay. Okay, all right, well, I'll show you. The point right there. Point is that 3D printing, the capabilities of 3D printing, you don't need me to go into, but it is something that NASA is exploring greatly, and so much so that we've actually, a former student of mine, Jason Dunn, started a company to build the first 3D printer on the International Space Station. A student of mine who I knew in college, actually he's much younger than me, came up with this idea and has founded a company with 30 employees that has office space at NASA Ames Research Center. So one idea went big. It continues. Many one ideas continue to go big. So the thing I just want to highlight and finish up with is that my goal, our goal as an agency, but also my goal as a company, is to be able to provide you, everybody, with the tools and the knowledge, okay, to be able to build the things that you need and that the agency needs, that we need, to explore space and to live sustainably on the Earth. So if you have any questions, feel free to email me or look me up on any of the social media, or just come up to me right now and chat. I think I have the translator thing here, so if anybody has any questions, by all means, please ask away. Thank you. Okay.
Quem quiser fazer alguma pergunta, primeiro fala se vai ser em inglês ou português, para ele ficar atento com a tradução.
Fazer em inglês. The technology today. The technology is made for improve the human life. So why spend all that money in discovering the space? If what kind of improvement this kind of technology is going to represent in our lives, like the human being lives?
No, this is a very important question. I get asked this all the time, and just to restate it, what impact does the money that NASA spend to develop these technologies for space, how does it impact everybody else? So there's a couple answers to that. The first answer is understanding how we can, as a species, live on other planets is something that the dinosaurs didn't have, right? I don't like that answer, but that's a common answer. It's like if we know how to go to the moon or go to Mars or fight off the risk of an asteroid, the fact is that investment can help us survive these certain to come eventual catastrophic events. However, the real, I think, down-to-earth answer to this is that NASA's job, and I think the government, all government's job, is to really help the citizens understand and either live their life in a happy way, or in some cases that means run a business. And NASA is charged by Congress to help commercialize technology that enables individuals to become business owners and employ other people to do these things. It is not the role of government to come up with the idea of what to do with this technology. I think it should be in the hands and the minds of you and the makers of everybody to be able to say, this is a technology that I want to do something else with. And if you think of water filtration is the obvious one. Rocketry, drones, all of these technologies that were originally within NASA's aerospace inventions have other applications that your job is to figure out. And that's what I want to help do, is figure out if your idea is good enough, will it save us money? And it will save, everybody money. So that's my real answer. But dinosaurs, though, yeah, that was important too.
Thanks. I'm going to ask in English. If gravity has taught me anything, is that space debris is a real problem. So with many satellites going up into the sky and everyone shooting a cell phone up there, how do you guys deal with that?
That's a great question. The fact is that the International Space Station is no more than miles. It's about 250 to 300 miles up in the sky. Okay, I don't know if you've seen it go by, but you can go online and look for the space station to fly by. It's something that you can actually see with the naked eye. That's not very high. And the station always requires a boost of fuel to be able to to be able to stay in its altitude. The small satellites that we're launching, that cloud of kicksats, those things last only a day or a week or 2 weeks, depending on the altitude. And one thing to think about for low mass satellites is that if you throw a baseball, you're going to be able to, and you put all of your muscle into it, you're going to get some distance. But if you take that same muscle and throw a ball of confetti, it's going to fall. And that's true in space too. It's a concept, the ballistic coefficient. And so lightweight satellites have shorter orbital time frames. And the value of using a cell phone is that you're dramatically reducing the weight. Planet Labs, with their hundreds of satellites, they're constantly re-entering into the atmosphere. So they're constantly having to launch them, which in turn has got a really cool economic benefit because now there's a big demand for launch services and there's a big demand for the deployer off the space station, which makes it cheaper for everybody else. So they're basically subsidizing the ability for everybody else to have a low-cost satellite.
Alguém mais quer fazer uma pergunta? Okay.
Okay. Well, cool. Thank you very much. And if anybody wants to talk to me in person, by all means, come up to me and we can talk.